Hello and welcome to today's webinar where we're going to be exploring using agentic design patterns to create autonomous agents within TotalAgility. So we'll start with a discussion of what makes an automation agentic. Then we'll look at some simple single task agents. So just recapping the basics of creating agents within the TotalAgility platform before moving on to look at how we can improve the performance and outputs from these agents using various different agentic design patterns. So we'll build on the examples that we start with to then fold in some of the agentic design principles and show how these can then work together to give you a more autonomous, more consistent approach to using artificial intelligence within your automation projects. We'll finish with a quick recap of some of the governance and management features available in the platform and then provide some links where you can go to learn more. So starting at the beginning, what makes an agent agentic? So an AI agent is a software application that attempts to achieve a goal by observing what's happening in the world around it and then acting upon it using the tools it has at its disposal to try and achieve the goal. An agent can reason, it can analyze information, it can draw conclusions, it can solve complex problems by breaking them down into smaller tasks and putting a plan in place to help it achieve the overall goal. It can act, so you're going to give the AI tools that it can actually use to take action. So that might be accessing information, searching the internet, writing a file, generating a report, whatever those actions might be that are appropriate for the use case you're trying to solve. The AI should be able to observe, it should be able to see the results from those actions and actually fold the data that it's getting back into its plan, course correct and react to those observations. It should also be able to collaborate, whether that's with other AIs or also with humans. So being able to pass messages between different agents. So if you've got a managing agent and it's passing tasks to worker agents to complete, it should be able to communicate with those. And likewise, if it gets stuck or needs help, it should be able to ask for help and bring a human in the loop. Planning is absolutely key. If you've got a complex goal you're trying to achieve and you've got a set of tools that you can use to achieve it, you've got to be able to plan how you're going to use them. So I think this is a little bit like we give the tools the Lego bricks, and then the AI needs to be able to plan and reason about how it's going to turn those Lego bricks into the model it's trying to build. And of course there's different ways it can achieve that and different outcomes that can be constructed out of those raw building blocks you're giving it. But the AI needs to be able to autonomously figure out what it's going to build and what's the most likely model to achieve the objective it's given. And it needs to be able to course correct or self-refine. So it needs to be able to learn from previous runs or learn from the outcome from an action it's tried to take and actually be able to fold that back into its plan, course correct and improve and take corrective action to allow it to achieve that goal. So being able to adapt its strategy and behaviour based on the circumstances. So these are some of the core kind of capabilities that we want to see in an agent. And we're going to look at how we can use agentic design patterns to improve its ability to work within this framework to achieve an outcome. And of course, you want to be in control as well. So we've got what I call the spectrum of agency. At one end, we've got highly deterministic automations. RPA processes are a great example where the automation follows the same set of actions every single time, through to these completely self-directed autonomous agents that are able to act and plan and course correct and reflect on how well they're achieving their goal all by themselves without any human intervention. So there's this spectrum of agency and it's down to you to look at the use cases you've got and work out what's the most appropriate level of autonomy to give your agents. For sort of high risk regulated use cases, you might want to have more determinism, but you might still want to be able to use AI within the context of that use case, but do it using tight guardrails. So constrain what the AI can do so it's got a level of autonomy, but only within the guardrails you've defined. So a simple, less deterministic agent might be a retrieval agent, which in TotalAgility we call the knowledge discovery agent, which goes and finds information from you using well-managed curated knowledge bases, for example, all the content and documentation that's associated with a case, or the standard operating procedures that you've defined for the process you're automating. Then we have what we'd call a single task agent, a worker agent, or a micro agent. So an agent that's got a bit more autonomy, but only within the scope of doing a single activity, through to a more autonomous agent, what we call a managing agent or a case agent, that is actually orchestrating a number of worker agents, maybe things like retrieval agents, maybe other automations such as API calls or RPA bots, but it's given much more control over how the process executes and choice over which tool or agent to call in what sequence to achieve the goal that you've given it. So let's move into a demo. So let's start at the very basics, creating a simple agent. So those of you who have been on these webinars before, who've seen some of the previous episodes in this series, will know that we define an agent in a standard way. We've got a chat interface, so we can talk to the agent in real time or exchange information using natural language with the agent. We've got an automation interface, so we can call it and trigger this agent. Perhaps it's triggered when an email arrives or a case is opened on the support system. And then we've got the guardrails, the logic, the instructions that constrain what the agent can do. It's using a large language model as the AI brain. This is what's doing the actual reasoning and provides the ability to use natural language. But we complement this with knowledge and data from the knowledge base or different databases and systems that it can access and retrieve information from. And we give it the tools and integrations and connectors so that it can actually take action. So this at the high level is the anatomy of an AI agent. Now we're going to start with a really simple agent. So all this is going to do is provide the core logic to chat and respond to interactions from a user. And we're going to start off with the most basic use case. So I'm just going to wrap an LLM inside an agent that then can be plugged into other components within our platform. And when we do this plugging in, we use a standardized set of inputs and outputs from the agent so that each agent is completely swappable or pluggable with another agent in the system. So when the system looks up which micro agent or worker agent to use, it doesn't matter which ones it's choosing. We don't have to remap data in and out of an API every time we call it. It's just a completely modular, pluggable, swappable unit of functionality, whether that's just talking to a system or whether that's completing a task and using some AI logic and large language models to provide additional intelligence. So this is really a universal wrapper for automations within the platform. So first of all, I'm going to create a completely basic agent. So I'm going to come into TotalAgility Studio, choose Quick Agents and create a new agent. And here you can see we've got standardized inputs and outputs, and here's the standardized outputs. And I can just give it some top level example information. So example AI agent. Let's give it 1 minute response time. Now this is just most basic way of setting this up. So literally here I'm just going to use a Gen AI control. I'm going to select the default tungsten provider. I'm going to pass in the prompt. I'm going to pass the prompt to the output, set the temperature, and then respond. So all this agent does is just talk to our default provider. So in this case, an OpenAI model. But it's just to give you the idea of how to set up one of these agents. Okay. And of course, if I want to, I can switch into the advanced mode and edit this agent here as well. So now I've saved my agent. Let's publish this agent. So that's now available to use. So I could upload a document if I wanted to chat to the document, but now I've got a default chat connection with my AI agent. Hi, how are you? And there we go, we can see our answer from our LLM. So that's the very simplest way of building an agent, and that uses the out-of-the-box user experience. Of course, we're going to look at how we can further customize these in a moment. So next, let's add a chat client. So that's the chat interface that we can use to communicate with that model into the picture. Now, if I want to build a custom form to hold this, the agent I've just built, so I'll come into user experience, I build a new form. Let's call this example chat interface. You can see I've already created a couple already previously. We can set some of the defaults, but anyway, we'll just go straight in here. Now, I'm going to add the component, the generative AI chat component here. Let's just give this a session ID. So we need to give it a global session ID. There we go. So that allows it to talk to the backend component. Now in here I can choose my provider. So here's the example AI agent I just created listed as a provider. I can configure whether I want that to work with an image or document, whether I want to remember what's happening as I go through the conversations. I might want to set a specific response type profile. So this is just a variable that holds information about the tone of voice to use, the persona to adopt. I can set data like seeds, which gives more consistency over multiple responses. I can choose to include case data. So if this chat agent is happening as part of a case, I can include some of the case data there. So it's automatically got context of the current case. And I can enable auditing and so forth. And I can pass in custom data if I've got custom fields set up on that agent. So let's just quickly set this to be full screen. Okay, and release that. So now I come back into my user interface. Again, I can say, hi, how are you? And we'll get a similar sort of response. So now I've created both my chat backend and my web front end to go with it. Next, let's take a look at one of the pre-built agents that's provided as part of TotalAgility called the Knowledge Discovery Agent. This really lets you do question answering either within a broader knowledge base where you've got a large set of curated data and content, so enterprise-wide information, or indeed just with the documents associated with a specific case. So this adds some of the tools and data that your agents can work with, and we'll make use of these later on when we get into the details of agent patterns. But for now, just at the high level, a knowledge discovery agent is essentially a pre-built agent that does advanced RAG. So it takes the question, it turns it into something called a vector, looks up related information or information in your knowledge base based on the meaning of that information, not based on keywords or language or so forth, but based on the meaning of the sentences in the slices of the document you're storing in the knowledge base and in the question that you're trying to answer. It takes those results, it does something called re-ranking, so it finds the most relevant results out of the broadest set of results that it brings back, and then we pass it into an agent so it actually formulates the answer for you. So this is what's called agentic RAG. So quickly take a look at this in action. So here's again a chat interface like we saw us building a moment ago. Here we've got an annual report that we've loaded into our knowledge base, and we can start asking questions of that annual report, and you'll see the chatbot comes back and gives us the answers, and it also gives us the references within the document where it sourced that answer from. So this is a technique called grounding. So essentially it is using the information inside the knowledge base as the source for the answers it's giving you, as opposed to its pre-training. So next we're going to build another tool that our autonomous agents or case agents are going to make use of. So here we're going to build a single task agent or a worker agent. So we're going to use the low code and no code interface in TotalAgility to create this agent, but we're going to have an agent that does a specific task for us. It uses a bit of AI, but it's going to do a specific task. So this now starts to add into our picture these worker agents. So these are more autonomous automations. And in this scenario, we're going to look at how we can use an AI to create a report for us. Okay, let's start with a quick example of how we can build a worker agent. So this is an agent that basically does one task. It's going to use some AI, but it's a modular micro agent that we can then use later on as part of a broader, more autonomous case management process. Okay, so I'm going to create this agent. Now this agent is going to format, let's call it a report formatting agent. And what this agent does is it's going to take as an input some text or markdown and format that using Tungsten's branding. It won't take long to run, so let's set a short expected duration. I'm going to use a different icon to the one, the default one, so one I uploaded earlier. And I'm just going to remove the limit on the input size because we might have quite a large report coming in. Okay, so now let's add some steps. So first off, I'm going to add a generative AI step. I'm going to choose my provider, so let's just use the Tungsten provider. So we've got a couple of different language models installed here, but I'm just going to use the default. Now what I've actually done is I've taken our style guide and then fed that through an AI tool to generate the prompt that I'm going to use. So let's just bring that in now. Okay, so we're using Markdown to structure this prompt. That gives the better guidance to the AI model, so it understands, the steps that it needs to follow. So you can see we've given it a detailed breakdown of what to do. And then next I'm going to add our input prompt here. So this is the prompt or the text that's passed into this agent. Right, so I'm just going to go ahead and save that. I'll set the temperature to 1. And then I'm going to save the output into our output variable. Okay, next I'm going to use a deterministic workflow to complete our process. So I've got one that I've set up earlier. This basically just takes the input into that workflow and then saves it to the user's storage container. So here it's expecting a file name, so let's just create a variable for the file name. Let's call that file name, for example, report.htm. Okay, and then the contents of the file is going to be the output from the previous step. And then I'm going to take the output from this step and save it to our output variable. That's what's going to get returned to the user or returned to the automation process that calls it. And then finally I'm going to end that process. And let's just give these slightly better names. So this is going to be format report using AI. And this is going to be save final. Okay, so now if I hit publish, I can go ahead and try this out. Now what I've done is I've created a fictitious report about the maintenance of an oil well, so let me just bring that in so we can see how that works. Okay, so there's my information for my report. Let's start that process. Okay, so let's run this report, run this agent, sorry, to generate the report. So I'll take a couple of moments to run. And then let's take a look at the results. So this is my storage folder. And you can see it's created a folder using the date to sort the order, and it's added the process ID on top. So here's my report. Just quickly open that up. and you can see it's applied tungsten branding to the text that I passed in, so formatting it nicely so it's easy to read and consume. So what this has done is created a completely modular micro agent or worker agent or task agent, whichever terminology you want to use, which does one thing, but that is now completely modular and reusable, so we can make use of that as part of a wider, more autonomous process, which we'll see in a moment. At this point, we've created some of the basic tools that we need to build our more intelligent agents. So we've got some tools, we've got some worker agents, we've got a chat interface, and we've got a top level kind of chat agent. So now let's look at some specific patterns that we can use when we design and implement these automations that will actually help us get better results from the way we're harnessing AI. So of course there's lots of different ways we can set up an agent. We can follow a set sequence, a deterministic path, we can execute things in parallel, we can do fire and forget and launch different processes that run in the background. We can have managing agents that manage individual worker agents, we can have tool use agents that make use of different tools, through to complete agentic workflows or agentic cases where we're handing off between lots of different agents, either running within TotalAgility or indeed running outside TotalAgility. 4 patterns then that we're going to look at are the reflection pattern, tool use pattern, so looking at tools dynamically from a registry and using them as part of the plan that the AI's got, or simply to route a task based on the request or the intent of the user. We're going to look at a planning pattern, or 2 planning patterns, plan act, where you just create a plan and execute it, and something called plan act reflect repeat, where the AI will actually formulate a top level plan but actually fine tune it in the course of execution, and also how we can implement a multi-agent plan. So really a design pattern is just a structured approach to how you're going to build your agent that means it's going to operate in a more predictable way, so giving you more consistent results as you run these automation agents at scale. And this is quite different to traditional automations, because the agentic design patterns allow the automation itself to be goal driven and to manage multi-step execution, not just single turn content generation. So this is using generative AI as part of a wider infrastructure rather than just using it as a standalone model, or as I say, like a traditional automation that just does one thing repeatedly exactly the same way. And the reflection pattern, it basically uses a LLM step or an AI step to review the output from a previous step. So often when you're generating content using an LLM, there might be data omitted, there might be inaccuracies, it might not be exactly what you want. Now, instead of having to just accept those variances in the output of the LLM, we can actually use a second LLM step to improve that. Now, there's a bit of a trade-off here. Of course, your agent's going to take slightly longer to execute, it's going to consume more tokens, but actually if that means we can get a better quality response, we don't have to have so much human oversight of what the agent's doing, that extra additional cost might be worth it. And we can also use the reflection pattern to essentially score how well an agent's doing. So if we give it a structured framework, some structure, so it doesn't have to make up every time how it's going to do the scoring, we actually give it some guidance on how we want it to evaluate the output from the previous step, we actually get a consistent way of monitoring and tracking how well this agent's performing its task. So in terms of our setup here, we've got the same tools and we've got the same worker agent, but we're just adding an extra step into the worker agent to make it more consistent, to get more predictable output, and to reduce the amount of human intervention that's required. So to illustrate how we can use reflection to improve the output from an agent or an LLM, I've taken the task agent or worker agent that we built earlier and added some additional steps. So here I'm using the advanced designer, and you can see I've got the same original step that we saw earlier, instructing the AI how to format the report, but then I've added a new step, and here we're providing instructions to the agent, telling it to act as a quality assurance evaluator. So its task is to critically evaluate the generated report. And we've given it some detailed instructions on how to rank it for accuracy, so whether it's included all the sections of the previous report, whether it's appropriate. Often you'll see an AI will generate some content for you but add in some additional commentary, such as, here's your report, I've finished generating, anything else I can do to help you, and so forth. So it's going to check whether it's just done what it was asked or whether it's added anything extra in there. And it's going to look at some of the design of that report. And then I've asked it to use a model to output the data into a certain format that we can then use for decisioning and gating the downstream processes. Now this is a relatively simple example here. So I'm going to output my data into a reflection model, and then I can use the data in that reflection model to see whether I'm going to loop again and basically have another try at doing that generation. Now we'll see later on a more advanced model where we actually pass feedback from the reflection into an earlier stage or a refined planning stage, but here we're just going to keep looping. But I've also put a limit on how many times we can go through this loop. So if it keeps failing, it's not going to be stuck in a loop forever. And then if it exits that loop and it saves the file, but it still had some errors reported, I'm going to add those into the response that we get, that we provide back to the calling agent or to the user. So if we look at one of these runs, so here I've got a job that I've run, and it's actually flagged up some of the issues. So here's some issues that the kind of thing you might encounter. So it's giving us a low score for accuracy because the AI's skipped a section, but it hasn't. It's given us a high score for appropriateness, but it's also highlighted some design issues, such as it's used poor color contrast using light fonts on a dark background and vice versa. So overall the reflection score was good enough to pass, but again we can tweak these kind of scores. Now this also gives us a way of essentially using an LLM to mark the homework of another agent or the output from another agent. So if we want to test and automate things like benchmarking how one agent performs, or if we change a prompt or change a model and so forth, using this what we call LLM as a judge, or AI as a judge, to mark and score the output from a previous step. Again, this gives us a way of quantifying the responses that we're seeing without having to use a human in every single loop. Now, of course, there's a trade-off here. Every time we add an additional AI step, we're going to consume more tokens, it's going to take longer. So it depends on your use case, the extent to which this kind of additional oversight steps is appropriate and makes sense. But it's a good way of reducing the number of human touches you need to get a high quality output. And you have to decide for your report, your use case, what's an acceptable pass rate or not. So, looking here, I should probably change the prompts so that any omitted content actually is an automatic fail. So of course I could go and refine my reflection prompt and change that to automatically weed out any of those scenarios that I explicitly don't ever want to happen. Next, let's look at a pattern that we call tool use. So here the AI is going to dynamically decide, either based on its plan or based on the intent or purpose it detects in whatever a user's typed into a chatbot, to pick a tool to run. So first of all, we're going to look at this in a more simple scenario. So this is going to be what we call a zero-shot agent. So it's going to have one chance to call the tool. But in fact, this could be something that occurs repeatedly throughout your agent. But here we're using the LLM to decide, based on the query, what API or tool or worker agent or knowledge discovery agent we actually want to use next to fulfill the goal that we've been given. One of the ways we can look up what tool to use is through a registry, but really there's different ways we can provide that information into the LLM. So within TotalAgility there's three different approaches we can use. So one is to provide a static variable listing the available tools and worker agents. So typically this is using some sort of data model It could be specific to that agent, it could be shared across multiple agents, and it gives you real fine-grained control about what APIs the agent's allowed to access and use, or what data it's allowed to access within a knowledge base. Now we can also do semantic intent routing. So here we use the knowledge base, the ability for the knowledge base to look things up based on meaning, to dynamically look up the most appropriate tools to use. So if we've got a large number of available tools, we can store those in the knowledge base. We can use the knowledge discovery agent to basically recommend which tools might be appropriate back into our planning agent. So that's for where we've got very large scale, high volume scenarios where we've got a lot of different options that the AI might want to take. So instead of giving all of that information to the AI every single time in the same variable, we can actually minimize the amount of tokens we use and make it easier for the AI to decide by putting this intermediate step in place where we look up the available tools based on the intent or the meaning of the next step of the plan that we're trying to execute, or what the user's asking for. And the third way is something called model context protocol. So this is a protocol that's gaining a lot of momentum across the AI industry, and here this essentially provides a new standard, a new protocol, like essentially a new API to be able to access and look up the data or the prompts or the tools that are shared by a third-party system. So we already support model context protocol within our chat agents in TotalAgility, and in our next release we'll be providing the ability to expose and services within TotalAgility via our own built-in model context protocol server, and also to be able to consume those as part of our process. So we've already got supporting this. You're going to see more features coming in future releases. So in terms of our architecture, this is now giving us an additional component, so we can now use our chat agent to dynamically pick which workflow, worker agent, RPA bot, knowledge base or API, etc. it is going to use to fulfill whatever the user's typed into the chat interface. This agent uses a pattern called tool use, and in fact if you've been following along with this webinar series, you'll have seen this agent in action a couple of times before. Now here we're using this for to provide a chat service. So essentially it's a chat agent sitting behind whatever chat client you're using, whether that's web chat or Teams or whatever. So it's pretty straightforward. We are going to get the session and the seed that we're going to use. So basically get the user session ID. This means when we call a tool later on in the process or in the agent, we execute that tool using the same identity as the user who's having the chat session. So we pick up their session ID because we're going to propagate their identity. If there's any attachments here provided as part of the chat session, we're going to do a quick analysis of those just so we can give some context to the AI step. Next, we're going to load in the tools that the agent's allowed to use. Now, this is using at the moment in this implementation a lookup list of existing processes on TotalAgility, but it could be we look up based on semantics, so we use a knowledge base of available tools, or indeed we could be using model context protocol. So we've just started to, we've just in the last release of TotalAgility announced and provided model context support, and in future releases we're going to expand that support as well. So this could be looked up using local variables, using a semantic search and semantic intent routing, or using a registry such as MCP. So we have a prompt that is going to basically review the user's inputs and route that as appropriate. So using the data we've looked up from the tools, we provide that as part of the prompt for the AI, and then it can use that information to decide what to do with the request. Now in this case it's a zero-shot agent, so we're only going to have one chance to reply. So anything that's complex, that requires multiple steps, planning, this agent isn't capable of doing it. But what we can do is call another agent, so launch another agent, in this case a case agent, that is then going to do that multi-step planning, and we'll see that in a moment. Or we could call a service or tool, so we could call a worker agent and just fire that request into a worker agent, get the result back and respond. Obviously the AI could respond directly, so if it knows the answer, maybe you're asking it, what sort of thing can you do for me? It's going to reply directly, or it could look up information from a knowledge base. So we've pre-configured this. So it's got a couple of different tool options, but really what it's allowed to do, it depends on what tools you give it in the registry. And of course you can have more advanced logic here based on user permissions and so forth. So let's have a quick look at that in action. So I'm just going to move now into my Teams environment. So let's start with asking what it can do. So this should trigger the agent to reply directly. So it'll know what it can do because it's looked up the various tools that it's got available. So we can see it's now replied. It's telling us what the kind of services it's got available based on the tools I've loaded into the registry. So we can search our knowledge base, we can call a case agent to run more complex work, we can manage files or add things to a knowledge base. So let's ask it about some TotalAgility APIs then. How can I get the history of a case using the API? So this, in this case, should reroute based on what I'm asking it to ask the question of the knowledge base. Okay, so now it's looked some data up in the knowledge base. Or I could, ask it to say, save this file in my storage drive. And off we go, and it's going to go and do that. Great, so that's now written that file to my storage drive. So you can see, based on what I'm asking it, it's dynamically routing to different tools, depending on how I've described the capabilities of those tools in the knowledge base, in the tool registry. So now let's go and have a look quickly at what happened at the back end and how it routed those different calls. So here are the three different agent calls that I made. I can see, one wrote the file to storage container, one asked my question, and one answered what things I can do. So let's just have a look at how those ran. So in this first agent, as we expected, it replied directly, telling us what it was able to do. This agent, for example, called a worker agent to write the file to our storage drive. So we can see now we've got complete audit trails of every action that an agent took. So we can quickly come back and replay these, understand how it responded, and giving us that transparency of the way in which your AI agents are executing. So next, let's look at how we can use AI language models to provide planning within the context of automation or orchestration. So here the best models to use are reasoning models, so more modern models that have the ability to break down tasks and hold memory and context for longer. So here there's a couple of different patterns that we can use. We can use a plan act pattern where, given the goal or task, the agent plans what it's going to do, and once it's got its plan, i.e. A sequence of steps across the tools it's got available. It just goes ahead and executes that plan. It doesn't do any reflection in between each step. Or we can use a plan, act, reflect, repeat step. So we combine the technique we saw earlier where once we've taken a step in our plan, we actually evaluate it. We use the language model as a judge to look at the response from that step of the plan and then work out, well, does it make sense to carry on with the original plan as we intended, or do we need to do some course correction? So this gives us a orchestration layer across the different tools, data sets, knowledge bases and actions that are available. So here we're using a longer running agent, so typically not one that's responding synchronously and straight away. Typically it's taking its time, it's going to have multiple different steps, so it's going to take a bit longer to act. And really it works very much like case management in traditional TotalAgility, with the difference being instead of having a human decide what's going to happen next in a case, we're using an agentic pattern to take those decisions autonomously. So here, so this screenshot shows the plan act pattern. So it has a step up front where it creates a plan. We store that plan in a data model, and then we use the data model to guide the subsequent steps that are going to be executed. Again, we're using this tool use pattern here to actually execute the different steps. So we don't need to predefine every route that the agent's going to follow. So really we're just providing a control wrapper around the execution of that plan, but what tools get called at what point are dynamically determined by the contents of that plan. So I'm not going to show this as a demonstration because we've got limited time and I want to get into a pattern that brings all these different principles together. But just to show you, there's a sort of intermediate level of agency that we can give the agent before we get into a full plan, act, reflect, repeat pattern, which is what we're going to look at next. So this pattern really combines everything we've seen before. It combines reflection, it combines tool use, it combines planning, and also it's useful for orchestrating across different agents. So within the back and forth between the different steps that the agent follows, you'll actually see agents exchanging messages and talking to each other. So this is really useful for complex, long-running problem solving using autonomous AI agents. And as I say, within here, we're actually, this is essentially a multi-agent plan because all the examples we've seen where we move between worker agents, so managing agents and delegating tasks to worker agents, waiting to get the response back and then using that response to further our plan, that's all part of this multi-agent pattern. So in terms of our architecture, we've got the data, we've got the tools, we've got a chat client to initiate this connection, we've got a chat agent that does the routing, we've got different tools and things it can choose from, but in this case our chat agent is actually going to trigger one of these long-running case agents. So we've got a real-time chat interface we can interact with, exchange messages with, but if we ask the chat agent to do something that's more complex than it can do in a single shot, in a zero-shot pattern, one of the actions it's allowed to take is to fire off a new agent that's going to be a long-running agent that's going to try and execute and complete that task in the background. And of course, it doesn't have to be initiated through chat. This could also work through an API, an automation connection. A file arrives, a document scanned, an email arrives that in turn triggers an event. So using a classic kind of mailroom pattern, we'll look at that message, we'll classify it, and then we'll route it. And one of the destinations we could route it to could be one of these autonomous AI case agents that's then going to pick that up and respond to it. So somebody could mail the bank and ask them, I want to change my address, I want to move some money from this account to that account, or call me back, or whatever it might be. It can read the email, it work out which agent's going to be the right agent to address that requirement, and then route it into that agent as appropriate. So this gives us a complete setup for both autonomous operation and supporting people in real time through chat interfaces, no matter where that document's coming from, where that event's coming from, or indeed what chat interface or chat client the person's using. And we're effectively sharing context all the way from these top layers in the architecture, all the way down to, you know, the tools and data that we try and use. And of course, you know, any events at the back of the architecture can then be sent back. So when a case agent finishes its case, you know, we could email the user, we could send a Teams notification back to that user, and so on. So this agent brings together several of the concepts that we have discussed previously. And this agent is designed to have a much higher level of autonomy. So initially what happens is when the agent's launched, we process any documents attached to the case. So we add those to a knowledge base that's tied to this case. So the agent's able to query and ask questions of the data that's associated with the case. We also look up the registry. So we look up what tools are available. In this case, we're using a static variable. As I said before, this could be a semantic search, so a semantic intent routing, or it could to find available tools or relevant tools for the use case, or we could be using an MCP or some combination to bring that in. But in this case, we've preloaded a list of available actions for the AI to take. Now we're also running within the case framework. So because this is a long-running ad hoc process, we don't know what tasks are going to be undertaken by the agent, but we use the case management harness that's provided by TotalAgility to manage the agent execution. So we add notes to the case. So we ask the AI to add notes to the case to basically tell us what it's thinking and what it's doing as it goes. We've also got an event listener set up, so if new documents or messages arrived for this this agent, we can add those in without halting the current execution. And then the core of the agent process is this planning loop. So in this agent, we're following a plan. So we have a planning step, we have an action step. So the output of this plan is an action to take. So that might be, you know, pass it to a human for a human in the loop review. It might be just is ready to reply. We might want to launch a long-running workflow. We might want to call a service. We might want to look up some data for using our knowledge discovery agents. We might want to call a worker agent like we saw earlier to do a very specific task. Or we might want to call RPA robots. So this agent's got a list of available tools and services and workflows, etc., that it can call, which is happens in this action step. Then we have a reflection step. So we actually use an AI to review the results from the last action and decide whether that fulfills the goal and whether we're ready to reply, or whether we actually need to take some more actions and more steps before we can complete the goal. And this might give guidance about what it thinks should be done next. So this contributes, the reflection step contributes to the planning step. Now we're also using some scoring. So I'll show you in a moment the scoring profile we've set up in this reflection step, so we can track that data as part of a work type or a job score and so forth. Now assuming it's not ready, we have this repeat step. So it goes back in a loop and it comes back and it says, okay, you know, this was what the last step did. This is why there's still some outstanding tasks that need to be undertaken before we can fulfill our goal. So it does this repeat step, and then we go back into this planning state, and we pass the outputs from the reflection step. So we've got a data model that we're using that contains the different actions that were taken. So here we're basically using a data model. So we're going to capture, you know, the sequence, the action, what the job ID of the worker agent was. So when we fire off another task, we get the ID back, and we can use that to, you know, look up data. So this is operating as a multi-agent management, you know, managing agent, a multi-agent workflow, however you want to describe that. We also get, you know, the response back from that action, the response back from the reflection agent, and so forth, and any errors that were raised. So when we do this reflection step, you can see here, you know, we're telling it what it's doing. We're telling it it's part of this cycle, so we're giving it the context. We're telling it, you know, how many steps are left. You're on, you know, where you are in this cycle. You know, whether we're giving it some rules. You know, whether it's nearing its step limit. We're telling it to towards completing the task rather than you know, keep finding little minor improvements. We're giving it the original goal or objective. We're giving it that history, that data model that we saw a moment ago, showing it what the previous, you know, the output from the previous steps. We give it a more detailed model which shows it the exact output from the last action. We're giving it some guidance on how files are used in the system. Because we preload all the files, we don't want the agent to get stuck asking it to do more file processing because we've already done those steps. So we're giving it more context, about how it works itself. We're giving it information that we got out of those file processing steps, and then we're giving it a framework on how to score whether it's ready to respond, including some information around error handling. So, and then when it outputs, we're giving it a data model to output to. So this is the you can see the reflection response data model here. So we're capturing that information as part of the data model that we're circulating around this loop. And so when we're also giving it a lot of information on that initial planning. So we're telling it what agent run it's on, where it is in its loop stage. Again, we're telling it it's part of this cycle, so it knows what role it's playing. We give it the original goal and so forth. And we're using, again, guidance and logic here to tell it how to plan its next action. And we're also loading in all the available tools that it's got to pick from as it completes the process. It's also worth mentioning it's always able to escalate to a human. We can give it some guidance on when it should take certain actions. If it's detecting a security or some sort of prompt injection, immediately pass to the human in the loop. Never rewrite URLs and so forth. It's okay to say you don't know. Always be honest. All these kind of top level pieces of guidance, but we're giving it the option to go and ask for help or to put it in a human queue for review, and then the human can decide whether this agent's run its course and we need to start again, or whether to allow it to continue. We've also got scoring rules are based on complexity. So this decision here, while it's based on the output of the reflection nodes, we're also having a maximum loop count. We're also looking at the job score, so we can dynamically decide that actually, this agent, for example, is costing too much because that's part of the the scoring rules, and then we can pass that to a human. And eventually, when it's ready to respond, if there's been multiple steps taken, we use another AI step to just summarize those, or if it's just replied in once, it goes straight through. Then we just update our audit trail, update our data trail before passing a response back to the user. So here I'm using, again, the Teams front end to talk to my chat agent. So as we saw before, that agent accepts the prompts from the user and then decides whether it can fulfill them. And in this case, I'm going to give it a more complex prompt. I'm basically going to ask it to process some questions in an RFP file, research the answers using the internet, using a knowledge base, and then prepare a report to respond to that RFP and format that using tungsten branding, so using the service that we set up earlier. So I'm going to kick that off. Now what should happen is it identifies that this is a slightly more complex request. So it's going to upload the file, identify it's a more complex request, and then pass that off to a case agent, so a long-running case agent, to actually do that processing. And that agent's going to break down the task. It's going to use the prompt that it's given. In fact, this AI is probably going to rewrite the prompt a little bit, but it's going to use the instructions and goals it's given, and then using a problem-solving approach, try and work out how best to respond. So here's the refined prompt, and here's the case ID of the new case agent we're running. So here I can see some of my agents running. So here's the agent we just kicked off. I can see it's in a planning state. I can see it's currently in its fourth iteration around the planning loop, and it's currently got a confidence level of 31% with the progress it's made so far. So it's clearly got some more steps to do, and I can control and manage this agent from here. I can also see the the chat agents and how they've been completed and so forth. Now if I come in to look at my agent, I can actually see every step that the agent's taken. So I can see that it's processed the documents, I can see that it's set up the original prompt, and I can see already, I'll zoom out a little bit, that it's been through a couple of rounds of the planning
implementation, the planning cycle. So it's currently looking stuff up in its knowledge discovery data set. So I can also chat to this agent while it's running. So, what questions are you working to answer? So it should have the data if it's processed that file correctly. So here we go, you can see that it's found the questions in there, and the AI, the chat interface onto my case agent knows what's going on. What is the current state of the agent? So it's currently in an acting state. So it's done its planning, it's doing another round of actually acting, and we'll see how long it's been running for so far. So I could also come in and chat to the knowledge base, so chat to any documents that have been loaded into the case, but in this case it's just the Excel file, so we saw that earlier. So I'll move on, but we can see what tasks it's taken. So I can see that it's been running queries on different knowledge bases. So it's running on the docs knowledge base and the question and answer knowledge base for TotalAgility. And I can also see the notes that it's adding to the case. So, it started with the original prompt. You can see it's added a note that it's done some of the document processing, and then we can see, each step, how it's reflecting, the original goal. The reflection step is looking at the original goal and seeing how, measuring how well that's able to achieve that goal with the steps it's taken so far. So this is going to carry on running for a little bit longer, so we'll come back to that in a moment and see what the end result is. So I can see that my agent's now completed and it's saved a file. So let's have a quick look at the report that it's produced. So it's produced a question and answer report. You can see here that it's got the 5 questions from the RFP from the Excel. It's formatted it quite nicely. It's an easy to see layout. And yeah, you can see that it's done a good job answering those questions.
So now you've seen different ways we can build, manage, design and optimize agents within the TotalAgility platform. And just before we finish, of course, one of the key things when we're deploying agents and managing them at scale is how we can actually manage and get transparency and clear operations, be able to monitor what they're doing, course correct. And of course, this is one of the areas where TotalAgility brings a lot of advantages as an agent management platform. So, we've seen things like human in the loop. We can do dynamic work allocation. We can report based on the type of activity or the work that's being done. We can fire events. We can trigger events. We can track different milestones throughout the agent's execution. And of course, we can manage state. We can wrap SLAs around these things, the agents. We can do random sampling to see how agents are working. We can apply different roles and personas and skins to those agents so they pick up different capabilities. We've got unit testing, benchmarking, etc. built in, as well as things like built-in versioning and automated deployment. So we provide a really robust platform in which to deploy, manage and scale these agents. So really this is, to summarize, how's our platform different? We're providing the capability to automate any document or any web content. We've got complete agent governance for transparency and control of the execution of your agents, and we're using the knowledge base that's built into the product so we can learn and understand your business and continue to improve as those agents execute. Okay, so, all we've got time for today, but if you want to learn more, or if you want to see any of the previous webinars in this series, just follow the QR code there and that will take you to a little microsite that's got all the previous material and some other links and information and documentation. So thank you very much for your attention today, and we hope to see you on the next episode in the How to AI webinar series.